Welcome to today's webinar entitled Top 10 Tips and Tricks for Hadoop Success. My name is John Kreisa and I will be your host for today's webinar. I'd like to start by covering a few housekeeping items. First, all lines will be on mute throughout the webinar. If you have a question, you may ask it via the questions panel located on your GoToWebinar console. If you are having difficulties, you can ask it directly to a panelist via the chat tool also located on your GoToWebinar console. Slides for today's webinar will be made available to all attendees after the event. We will have plenty of time for questions, and you may submit a question at any time during the event. Many of you may be just starting out with Hadoop and are looking to avoid the mistakes made by others, while others of you may be well into your Hadoop deployments and looking for some additional tips to speed your deployment and success. In our webinar today, Cloudera's support and services team will draw from their experiences in the trenches implementing Hadoop in small and large enterprises. We have focused the content for today's webinar on actionable steps to help you successfully deploy Hadoop. These top tips and tricks are guaranteed to save you time with your deployment, and I'm happy to tell you that we will exceed the promised 10 tips and tricks and bring you far more insight and help on your way to successfully using and taking advantage of Hadoop. I'd like to now introduce today's speakers. Omer Trasman is responsible for all aspects of services and support at Cloudera. He regularly works with customers to understand how they're using Hadoop and to help them decide on the best strategy to meet their needs. Alex Lundgaard is a solutions architect and support team lead at Cloudera. He works both in the field, helping Cloudera customers build and deploy their Hadoop-based systems, and coordinates inbound support requests. His experience with Hadoop ranges from basic installation and configuration to hands-on deployment of multi-hundred node clusters. Now, I would like to turn the presentation over to our first speaker, Omer. Omer, you have the floor.
Thanks, John, and good morning to everyone on the West Coast, good afternoon to everyone on the East Coast, and I guess good evening, perhaps, if you're watching this from Europe. We're going to be talking through a number of different things today. Just to give you a brief background, if you're not familiar with Cloudera, about who we are and the services that we provide and how we've gained all this rich wisdom that we're sharing with you today. I'll talk about a few typical deployment architectures, cover the different components that make up a Hadoop cluster, and then hand it off to Alex, who will go through several performance tips for optimizing your Hadoop cluster, standard tips and some tricks and mistakes that you want to avoid. And then we also get a lot of questions nowadays about HBase. So Alex is going to talk about HBase and HDFS considerations for those. As John mentioned, we'll take questions anytime throughout the webinar and make sure to address as many of those as we can towards the end. So without further ado, we'll take a look at the next slide and tell you a little bit about who we think you are, who this webinar is geared towards. So we've targeted this towards people who have used Hadoop or are familiar with it, who are planning a Hadoop deployment, looking for advice on how to get started, have deployed a Hadoop cluster looking to get that into production, or someone who's in production with a Hadoop deployment and has run into any issues and is trying to figure out what to look for and what steps to take next. We want to ask you guys a quick poll just to find out a little bit more about you and how many people are aware with their Hadoop deployment. So if you could just select one of the following in answer to where are you with your Hadoop deployment. If you've just heard about Hadoop, if you're just getting started with your deployment, if you're putting it into production, if you have Hadoop in production, or if you don't know anything about Hadoop and you came here to learn. The polls are streaming in. I'm happy to say that the majority of you are getting started with your deployment. I'd say about an even split between just heard about Hadoop, putting into production. Actually, a fair number of you are in production. It looks like very few of you are just here for the first time learning about Hadoop. We will cover that. There's a lot of great material also available on Cloudera.com, and we'll give you plenty of links to learn more background about Hadoop. I'm going to go ahead and close the poll here, and John will be able to share the results with you. And there you go. So I'm very happy to see that a bunch of you are just starting with their deployment. This is actually perfect timing. You'll learn a lot about how to prepare for that. So next on our agenda, we're going to tell you a little bit about who Cloudera is, if you're not familiar with us. So we're providing enterprise support for Hadoop. We have a full software package that provides you Hadoop, the various packages related to Hadoop, additional operational management tools that we've developed to make Hadoop easier to deploy and to manage. All of that based on Hadoop open source software from Apache. Our founders actually built very large Hadoop clusters. They came from Google, from Facebook, and from Yahoo. And of course, one of the members of the team, Doug Cutting, actually originated Hadoop when he was working on the Nutch project 6 years ago now. Our product is Cloudera's distribution for Hadoop. We give you all the necessary packages matched and tested for that. And we also have contributors and committers who provide fixes, patches, and add features to Hadoop. We also make our customers successful using a variety of different offerings. We offer training. There are comprehensive courses and labs available online, as well as certifications. We offer consulting services if you need architects for design and optimizations. These guys have built some of the biggest Hadoop deployments available. We offer support. If you have questions, need to address any critical issues, need help keeping your Hadoop cluster running day and night, and advice in the form of knowledge base with best practices, updated checklists, tips and tricks, a lot of which you will see today. So the next thing I want to cover is some typical deployment architectures. I'll actually talk through the different components for Hadoop and then show you where Hadoop fits within your enterprise. So when we look at Hadoop, we're actually talking about roughly 4 different components. Hadoop core itself is composed of the MapReduce component, which is actually where all the execution work gets done, all the processing gets done. HDFS, which is a distributed file system for storing large blocks of data. HBase, which is a column family database that runs on top of HDFS. And Alex is going to go into more details on the differences and comparisons between HDFS and HBase, and various client applications that run on top of this. All of these actually come in 2 components. The first component is the set of masters, and there's basically one or a small number of masters for each of these components. HBase has a master that gets elected using Zookeeper, which is a distributed coordination system. MapReduce has a job tracker to keep track of all the jobs that are running on the system. And HDFS has a name node and a secondary name node. The name node's responsible for keeping track of where all the files are. And the secondary name node's actually like an online defragmentation. It takes data from the name node, organizes it better, usually running on a different machine, and then provides that back. So it's optimal to access data and files that are on a distributed system. All of these also have worker machines, and you can have any number of workers for each of these systems. So in the case of HBase, you have region servers. These are providing the data and serving the data out of HBase. MapReduce has task trackers that are actually executing the different tasks of MapReduce, and HDFS has data nodes. And we've stacked them here because they're typically co-located. So the idea is that the region server is serving data off the data node, and the task tracker is accessing data from the region server and from the data node. So we're minimizing data movement by distributing the data and distributing all the computation to as many workers as you need. And Hadoop can scale up, as many of you probably know, from tens to hundreds to thousands of workers as your data set grows and as your computation needs grow. In addition to the workers and the masters, there are several different client components that you use to access Hadoop. Hive is a SQL interface on top of Hadoop. You can use it to do things similar to data warehousing for the complex data that's in Hadoop. Pig is an implementation of Pig Latin. This is a language that was developed at Yahoo and is very good for ETL, for data transformations. Streaming is actually a mechanism within MapReduce where you can plug in any kind of executable that you want and use that for mappers and reducers. So if you're familiar with Perl or with Python, you can actually write in those languages and run your MapReduce jobs just as you would with any other structure. And of course, the native underlying implementation in MapReduce is Java, and writing in Java MR is writing to the native MapReduce interfaces. So we have one slide here that shows you all the different components pieced together. And hopefully this gives you some context to what we'll be talking about when we talk about the different tips and tricks as they relate to each of these different components, optimizations on each of these. I also wanted to show you a big picture slide of where Hadoop fits within the enterprise. Now you're probably familiar with the top of this stack, business intelligence software, having data marts or enterprise data warehouses, and interactive applications or OLTP data that's serving to end customers. Hadoop is really designed to sit in the back of all this. Batch storage, large storage, batch processing, where data collection resides, and a tool for your data engineers and your data scientists to understand how your business operates and provide more intelligent information to the data marts and to your end customers. So that's where we see Hadoop fitting in context. So next on our agenda, I'm actually going to hand it off to Alex. Alex, as you saw, is one of our solution architects here. He also organizes our support team. He's seen quite a lot of Hadoop in action at a number of our customers. He's seen some of the largest Hadoop and HBase installations out there today. And he's going to share with you, starting off with some performance tips, and go from there. Alex, it's all yours.
All right, thanks, Elmer. So I guess the next bit of slides here, performance, tricks, etc., are kind of meant for you guys who are using Hadoop or who know a little bit about it, etc. So I think this should be pretty interesting for learning just what it takes to really run Hadoop and whatnot. So we'll start off with performance tips, kind of the critical list. I mean, obviously it's complicated to make things perform well and whatnot. So I'm trying to summarize kind of the big ones here. And to start, we'll talk about hardware, right? This is the probably most common question that people have when they're first getting started with Hadoop. What hardware should I buy? Should I have more disks? Should I have more processors? What's the right kind of balance there? Then we'll go into how to monitor that hardware, which is very important. You want to make sure that things are running correctly, etc. Then we'll go into the much desired Hadoop configuration. This is what most people kind of, I think, want to know, and it's not as much voodoo as you might think. So, but I'll shine light on that and go through it. And then finally, and equally important, optimizing your code. You know, if you have a cluster that's tuned and working perfectly, if the developers who are writing code aren't, optimizing their code, then whatever you're doing with the cluster won't really be as impactful. So we'll kind of run through these specifically and one at a time and talk about them individually. Cool. So hardware. It'd be really nice if we could just tell you, buy this hardware. But unfortunately, it's not that simple because each customer or each user of Hadoop has a different workload. So lots of people use Hadoop just to store their data and then maybe do simple aggregates or greps or searches, very, very simple uses of Hadoop that are typically more I/O bound. And maybe they want Hadoop as an economic storage and light processing engine, right? And in that case, most people are going to kind of have I/O-bound processes, and they're going to want to have more storage-heavy clusters. So in that case, we typically recommend that people have more spindles per core, more disks per core. We see a lot of 1U machines with maybe 8 disks, or 2U machines with 12 disks, and maybe 8 cores and 16 to 32 gigabytes of RAM, depending on kind of your needs there. But the point is that if you're trying to store a lot of data and you're I/O bound, you can have a really storage dense cluster with lots of disks. Most commonly we see people with 12 disks in 2U, or maybe as high as 10 disks in 1U. Similarly, or differently, if you're CPU bound, so if you're maybe doing machine learning, if you're maybe doing Bloom filters or clustering or anything much more kind of CPU intensive, much more processing intensive, then typically what we recommend here is to maybe save some power and some money and not have as many disks per core. In this case, we might see for a given customer maybe 2 disks, or 2 disks is probably very low, but more commonly 4 disks per machine per 1U, with maybe 8 cores or with maybe 8 cores and then 16 to, like I said, 32 gigabytes of RAM. Again, it's kind of typically we recommend kind of a nice balanced cluster to have maybe 2 gigabytes of memory per core, and then maybe 2 cores per every disk. That's kind of a nice balanced cluster there, and that'll give you plenty of breathing space for if you have slightly more CPU bound processes, and also plenty of disks so that you can still store a good amount of data and whatnot. And in addition to thinking about CPU bound and I/O bound processes, you might even have a memory bound process. And as we'll see later, if you're interested in HBase, typically we recommend having more memory than you would otherwise have if you're going to run HBase. So we might recommend 16 to 24 gigabytes of memory per machine. However, if you're running HBase, maybe 24 to 32 gigabytes of memory. Really, I guess what I'm trying to shine light on here is that we can't just tell you the exact hardware to buy, because it's totally dependent on kind of what you're doing. And it's really a chicken and egg problem too, because you have you might not know what your workload is. You might not know what you're trying to do, and so what often organizations will do is, and we recommend this, is to maybe start with what you think is the right hardware for you, or maybe go with a more balanced route, and then expand the cluster later with hardware that fits your needs more. It's totally normal and not cumbersome to have a heterogeneous Hadoop cluster. I mean, sure, it would be great if we could have our hardware perfectly matched to our workload, but it's often kind of hard to do that, just because, like I said, it's a chicken and egg problem. So don't fret too much if you maybe should have had 2 cores, or sorry, two additional disks, or 2 additional cores or something like that, because you can have a heterogeneous cluster pretty easily, and you'll go through it. So there are more details at this link. So if you click through there, a lot of what I talked about is summarized, and there's some other good stuff there. So moving on. Okay, so just as important as buying the right hardware is monitoring that hardware. Like Omer had said previously, Hadoop is deployed anywhere from tens to hundreds to thousands of computers, and the more computers you have, the more important monitor becomes, because it's if you have lots of machines and one of those machines is running really slowly, Hadoop is going to try its best to maybe blacklist that node, or not, eventually kind of ignore that node. But at the same time, small performance hits to an individual machine can actually impact things fairly largely. In fact, more largely than you'd probably expect. So we kind of urge our customers to really invest a lot in monitoring. You want to make sure that your NICs are running at gigabit speeds. Sometimes if a cable's not set, or if there might be some issue with the cable, or maybe the network interface is busted in some way, you want to make sure that Ethernet is running at gigabit speeds and not at 100 megabits. So you can use eTool to do this. In addition, you want to make sure that disks are performing well. You know, Hadoop runs on kind of industry standard hardware. It doesn't run on enterprise hardware. Well, it does, but this isn't something that it's not a requirement. And so it's really common to have these disks fail or these disks go slowly, and so you want to try to stay on top of disk performance using IOstat. There are other ways to do this as well. Like there's a tool called PM Info, which works well, and so you can go with that. But it's pretty important to make sure that disks are performing well. Hadoop, even if you're doing more CPU-bound processing, you're still going to be reading a lot from disk, and it's still important that those disks are performing well. Let's see. So alongside disks performing well, also you want to make sure that disk controllers are performing well. Oftentimes it might be hard to figure out which one of these is wrong, but if you see that one disk is performing slowly versus all disks performing slowly, then you likely have a controller problem versus a single disk problem. So keep that in mind as well. And then lastly, and probably most difficultly, confirm that your network is running fast. This is often much more tricky because you know, it's harder to kind of see how the network's performing. Usually if you're running monitoring tools, like I'll describe in a second, Ganglia or Nagios, they might be affected by a slow network, and which makes it even harder to diagnose. Using ping specified payload can help. Lots of other tools. You know, if you buy network hardware, it should come with tools to tell you how the network's performing, if there are packets being dropped. You can also use ifconfig to tell you if packets are dropped, that sort of thing. But again, with all of this, it's really, even though Hadoop does do a good job of trying to blacklist nodes and you know, take slow nodes out of the cluster, it's still important for you to try to stay on top of this. And if you have maybe 10 or 20 nodes, one problem is going to be pretty obvious, and it should be pretty easy to diagnose. But if you have hundreds of nodes or thousands of nodes, then it's really important to have this monitoring in place that tells you when there's an issue, and so you can go and fix it or take the node out of the pool and ultimately cause your cluster to run faster. And some tools that are really handy for monitoring are Ganglia and Nagios. So Ganglia is kind of this very scalable tool that's been around for a while, and it's really good at showing you how the network is performing for each node, how the network is performing for all nodes, how disks are performing, what the load is for each node, etc. It gives you a really good kind of high-level overview of your cluster and how things are loaded and where work is being done, etc. And so Ganglia can really help there. And actually, in addition to that too, Ganglia is really handy for you to try to learn if your processes are CPU bound or IO bound. So there are these nice graphs that show up with Ganglia that tell you how much disk is being used, how much network is being used, and how much CPU is being used. And when you run a typical job on your Hadoop cluster and you have Ganglia set up, you can kind of see what the job characteristic is based off of the Ganglia graphs. The one thing that Ganglia does not provide to you, though, which is still critical, is alerting, which is kind of where Nagios comes in. You can set up Nagios to alert on whatever you want, if a daemon goes down, if a NIC goes slow, anything like that. I mean, lots of it's very pluggable. It's very easy to kind of get monitoring in place with Nagios. So these tools are really handy for trying to really make sure that your hardware, you're getting the most out of your hardware. Okay, moving on to Hadoop configuration. So there's, as you may or may not know, there's a ton of configuration options out there. Some of them are important, some of them are not important, and it's often tricky to figure out which ones are important. So what I've tried to do here is I've tried to, in one slide, kind of summarize the performance specific configuration parameters to try to tell you, how you can maybe tune your cluster, how you can improve things. And so I'll kind of just go down this list and describe each of these in a little bit of detail and tell you why we recommend things. So the first one here is the io.sort.factor. And what this is actually I should take a step back and tell you just briefly kind of how MapReduce works. There's a map phase, right, where you write a map function and your map function outputs intermediate key and value pairs. And then there's a reduce phase where the reducer will get a key and all the values that occurred for that key. And in between the map and the reduce phase, there's a shuffle phase, which is a combination of fetching data from the mappers to the reducers and sorting that data and merging it. So the system does all that for you, and some of these configuration options here are ways for you to tweak that shuffle phase to make it run faster, to make it perform better, etc. So the io.sort.factor tells MapReduce how many different files it should merge together. So the default here is 10, and we recommend increasing this a lot. The only price you pay when you increase this is you have more open file handles, which is okay. But this is a great way to kind of make that merge process happen much more quickly. If you up this a lot, then there'll be a much faster merge. So we recommend just setting that to maybe 64 instead of the default of 10. Similarly, there's the io.sort.mb, which is the number of megabytes to use for the actual sorting. So the sorting is a quick sort, which can spill onto disk, and if you have plenty of memory available, then you could increase this even more to ultimately make that sort phase faster. And so the default here is 100, and we recommend maybe starting with 256. But again, if your jobs are not that memory bound and they're instead maybe I/O bound, you could up this even more so that you're using more of that memory for sorting, which is something that an I/O bound process is going to really get a lot of performance boost from. So kind of a good general value for this is maybe 256 megabytes, but again, this is kind of specific to your machines. If you have plenty of extra memory, there's no harm in upping this, and fiddling with it and seeing what the right thing to do is. I see there's a question. What unit is sort factor? There is no unit, so it's the sort factor is just the number of streams to merge at once. So there will be data. So for an individual reducer, there will be intermediate keys and values coming from lots of different mappers, and so maybe there'll be 100 mappers that contribute to one that gets sent to one reducer, and the io.sort.factor will tell you how many of those different streams will be merged together at once. So there is no unit, but I see there's another question too. Will the slide deck be made available? It will be made available. So you guys will have this later. I know that you're probably all hustling to write these down. We'll give them to you, I promise. So anyway, moving on, I guess. So io.sort.mb, I think I covered that pretty thoroughly, but keep the questions coming if you have them. Okay, mapred.reduce.parallel.copies. This is a pretty good one. What this does is, like I said, there's a phase in between map and reduce where the output of the mappers, the intermediate keys and values, gets sent to reducers. This configuration option, mapred.reduce.parallel.copies, specifies how many copies will get pulled from the mapper machines in parallel. So I forget what the default value is for this, but what we recommend setting it to is roughly the number of machines you have times the number of mappers on those machines, kind of divided by 2. I mean, this is a little bit of voodoo, but basically the takeaway with this configuration option is that you want to have as many copies going from your mappers to your reducers as possible without kind of bogging down your machines with too many concurrent network transfers. So a good rule of thumb is number of mappers per machine, number of machines divided by 2. But again, this is one of those options that you might want to kind of tweak and really benchmark and see how things go. But that's a good rule of thumb. And again, parallel copies is the number of copies that are transferred from the mappers to the reducers in parallel. This next one, MapRed, Task Tracker, and then this is 2 configuration options built into one. There's MapRed.TaskTracker.map.tasks.maximum, and then the same thing except for reduce. And what this is this effectively controls the number of map and reduce slots on a single machine. So you would set, MapRed, Task Tracker, Map Tasks Maximum to maybe some number slightly smaller than the number of cores you have. So maybe if you have 8 cores, maybe you would set that to anywhere between 6 and 10 or something like that. Again, this is so dependent on the hardware you get and kind of the workflow that you're doing. You would also set the reduced tasks to probably be something less than the mappers. And you would want the number of map tasks and the number of reduced tasks to be strictly greater than the number of cores, so that you can make sure that you take advantage of the multi-threaded nature of the cores and of just the whole process in general. So so again, what we recommend here is these configuration options. The task maximums configure the number of slots in each machine. And there should be more mappers than reducers, because it's in most cases in MapReduce jobs there are more mappers than reducers. And you should make sure that the number of maps and reduces combined is greater than the number of cores. So again, if you have 8 cores, then you could set the number of maps to be anywhere between 6 and 10, and the number of reducers to be anywhere between 4 and 6 or 4 and 8 or something like that. Again, kind of play with it, see what's best for your workload, see what's best for your hardware. Moving on, so this next one is speculative execution. Here, I'll describe speculative execution briefly. Speculative execution is an optimization in MapReduce. Since the reducers need to wait for all the mappers to finish, there could be a problem where one of your mappers is on a slow machine or something, and that mapper is going to run really slowly and cause everything else to go slow. So and cause the reduce phase to start more later. It'll start later. So the speculative execution lets you basically tell MapReduce to run a mapper in parallel for a mapper that's going slow, and if that mapper, if one of those, it effectively takes the first one that finishes and gives it to the reducer. So it's an optimization to make sure that slow machines are not slowing down the whole process. And we recommend definitely setting this to true for map and for reduce, especially in large clusters when there might be a slow disk somewhere that you don't know about or something. You can set this to false on small clusters, because in that case, most of the time you'll know if there's a hardware problem, and so setting that to false will kind of, I guess it'll be a monitor in and of itself. It'll tell you if there's a problem because the map's going slow or something like that. So speculative execution is in general good. Okay, moving on. So tasktracker.http.threads. This is the number of HTTP threads that the task tracker will have in its thread pool, and the reducers fetch the intermediate data from the mappers via an HTTP call. And so just like mapred.reduce.parallel.copies, you want to increase tasktracker.http.threads to roughly the same value for mapred.reduce.parallel.copies. Because you want to make sure that there's plenty of threads to transfer that data to the reducers when they're fetching things. I see there's a question. Oh yeah, actually, guys. So I guess there's a bunch of questions coming in. I'll keep running through this, and then I'll do we'll address the questions at the end of this slide at least. So going through the LZO, this is going to be a little bit quicker. Basically, in the tests that we've done and the benchmarks we've done about different compression algorithms, we found that LZO is the clear winner, both in the amount of data that's compressed and also the speed at which the compression and decompression happens. So we highly recommend having your input data, your intermediate data, and your output data be LZO compressed. When you want your input data to be LZO compressed, you need to store your data as LZO files. We recommend sequence files, which work very nicely with Hadoop. So you'll have to kind of do some ETL to get your data into an LZO sequence file state. But then once that's the case, reading the MapReduce jobs you'll have your input be LZO compressed. And then these configuration options that I've listed below here are the ways in which you can control the intermediate and output data and how it's compressed. So I think these ones are pretty straightforward. MapRed.output.compress, whether or not the output of a MapReduce job should be compressed. MapRed.output.compression codec, the available codecs to use for compression. MapRed.output compression type, the actual compression to use. The codec is a list of available codecs, and the type is the actual codec that you want to use. And then there's MapRed.compress.map.output. This is the intermediate data. You want to turn that on to enable intermediate compression. MapRed.map.output.compression.codec. This is the number of available codecs, or sorry, not the number, the list of available codecs for doing the compression. And then there's another one too, which is the same thing but type, and that's the actual codec to use. There's a lot more about this stuff at the link there, the Cloudera-LZO, tiny URL, and I highly encourage you guys to go there. There's some more detail. There's some actual code and examples and that sort of thing. So lots there. So I guess with that, why don't I take these questions? Oh, okay, sorry. I'll take the questions all the way at the end. Okay, so moving on. Okay, cool. Source code. So I'll run through this a little bit more quickly. Basically, like I said, having the source code is optimized is just as important as having a nice running cluster. There's some really easy ways to make sure that your MapReduce job is optimized, and these are definitely things that people who are writing MapReduce jobs should be doing. One is to use a combiner. The combiner is a mini reduce that runs on the map output on the map machine before the data is fetched to the reducer. So a combiner can make a huge difference in the amount of data that's transferred between the mappers and the reducers, and on the amount of work that's done on the reducer to merge and sort, etc. So highly recommended to use a combiner. We recommend also to implement a custom partitioner if necessary. So what happens sometimes with the default partitioner is that the reducers, the keys that go to each reducer is determined by the partitioner, right? And if you're doing, let's say, word count where you're trying to count the number of words, the words the, a, and, etc., these are all going to get huge numbers of occurrences. And so what if one reducer is tasked with processing the words a, the, an, he, she, etc.? That reducer is going to have way more work to do than all the other reducers. And so what you can do is you can create a custom partitioner, which in this example I've been going with, would just special case these stop words and make sure that they go onto different reducers. And the partitioner can really help for kind of dispersing those big keys that might cause reducers to run very slowly. So definitely, in a lot of cases, you don't need to do a partitioner, but in some cases, if your key space is very heavy, and then those big keys are going to, those big keys are going to one reducer, then we'll do a custom partitioner. Real quickly, make sure the input splits you're processing are roughly 64 to 128 megabytes. If they're smaller, then your job's going to go slower because it's going to be waiting for tasks to start. If they're larger, then it's likely that they'll be doing kind of, you can further parallelize your jobs. Make sure you don't rely on external resources, or if you do, make sure you know what you're doing. A lot of people will do a database call in their mapper, and they'll bring their database to its knees and really slow the whole job down. So if you need to rely on an external source, keep that in mind. And make sure you run with many reducers. A lot of people want one reducer just to have one output file, but that just doesn't work when you're talking about a lot of data. So make sure you have lots of reducers. And lastly, with regard to code, if you have Hive or Pig jobs that are that have made their way into like a batch job that has an SLA or something, you may want to consider re-implementing that in Java, because Java will, in most cases, perform better than Hive and Pig. And so these common jobs that are taking up a lot of the time on the cluster can often be optimized a lot by just writing them in MapReduce. Okay, moving along here, tips and tricks to avoid. I'm going to go through these kind of quickly. You can't do a rolling upgrade of HDFS and MapReduce. So if you need to upgrade the cluster, you need to stop HDFS and MapReduce, upgrade the cluster, and then start it again. You can't do it in a rolling way. make sure that if you have task trackers that are running and if your cluster's on and people are using it, don't fiddle with the jars that are in the class path of the task tracker. You need to stop the task tracker, fiddle with the jars, then start it again. Otherwise, you're going to have tasks fail because they can't find various classes. Really, really important here, stay on top of the dead node list and FSCK. You know, you can have a lot of monitoring on daemons and that sort of thing, but what really matters at the end of the day is which data nodes are registered with the name node and which aren't. So stay on top of the dead node list. Similarly, stay on top of FSCK to know if any of your files are missing blocks, and so some users might use a replication factor of 1 instead of 3, and then if a disk fails or something, then some of that data is going to be lost because they have a replication factor of 1. FSCK can tell you about that, etc. And also, super important, make sure you back up the name node. You should do nightly or hourly name node backups to avoid user error, so you can roll back if you need to. And you should also make sure that dfs.name.dir is writing to an NFS mount in the event that there's a catastrophic name node failure. We have a lot more information at the link below. So again, I'm just going to kind of power through these. When you stop a daemon, like when you stop a data node or a task tracker, sometimes the actual Java process is going to run for just a tad longer than after the stop command returns with a good return code. So make sure you pause between stopping and starting, or even do a little for loop to make sure that, a little bash for loop to make sure that the Java process is finished before you try to start it. That's definitely kind of hit a lot of people in the past because they'll do a rolling task tracker bounce or a rolling data node bounce, and some of the task trackers or some of the data nodes won't start because when the start command was kicked off, the daemons hadn't stopped yet. So that's a one that a lot of people don't really realize. This is really key, and I can't stress this enough. Test your jobs on small data sets first, and if you can, do it on your local machine. A lot of people will be running big jobs on a cluster that just eat up the cluster and cause other people to have to wait, and also don't let you iterate quickly on your job. If you're trying to tweak a MapReduce job and the MapReduce job runs for 20 minutes, that's much better than, or that's much worse than having it run for a minute and then being able to iterate, etc. Keep daemon logs for 30 days. This is handy, so if you ever need to do diagnosis or forensics, this is really handy. Archive history and job conf logs indefinitely. If you go to our blog, we have a nice blog about log files and where they live. So go there if you want to see a little bit more information about that. But definitely job history and job conf you should keep those indefinitely so you can compare, benchmark, etc. Set up Ganglia in a scalable way. With tiered gmod collectors, the Ganglia website has a lot more information about this, but basically you want to have a scalable kind of tiered gmod setup so Ganglia can scale. Going through these again, make sure that HDFS and MapReduce are rack aware. There's a topology script in the configuration that you need to set. It's pretty straightforward, pretty well documented. Make sure you test the topology script before you deploy it, because then you might actually have, if you have 2 racks, if your topology script is wrong, then maybe it'll be putting nodes in the wrong rack, or it'll be creating like a default rack or something. So make sure you test that pretty thoroughly before you deploy it. If you have a large cluster expansion, go from some nodes to many nodes, make sure you do an aggressive balancer, because those balancers can take a lot longer than you expect. And you can control the aggressiveness of the balancer with these 2 options: DFS balance bandwidth per second. Maybe set that to like 20 megabytes or something for a really aggressive balance. And then dash threshold, which is the threshold at which the cluster should be balanced. Set up a dev cluster to stage changes. This is key, so you can try things out, and if they don't work, then maybe you messed up the dev cluster, you didn't mess up the production cluster. And also canary whenever possible. One nice thing about data nodes and task trackers is that if one of them fails, the system's fine, right? This Hadoop is fault tolerant, so canary whenever you can. Maybe change the configuration on one task tracker and before you do all of them, etc. Moving on here. So I know you guys still have questions, but we'll do them just at the end of this. I'm almost done here. So moving on. So we've seen some performance tips and some tricks and mistakes to avoid, and now we'll kind of talk about HBase, because like Omar had said at the beginning, tons of people come to us about HBase, and I think for the most part, a lot of people don't understand it fully and don't understand what it's really used for and what its power is. And so we're going to try to shine light on that show you how you should use HBase versus HDFS, how they compare and contrast, etc. Briefly and quickly here, basically HBase is designed for several things listed here. Reference data, like if you need to if your mapper or your reducer needs to look up some reference data, HBase is great for that. Key value lookups, right? That goes just alongside reference data. Fast range scans, so HBase is really good at kind of looking at a range of keys and scanning through those there. HBase lets you update and delete individual records, which, as we'll see in a little bit with HDFS, we're not allowed to do that. So a lot of people have workloads that require updating and deleting individual records, and in that case, HBase is probably what you want, not HDFS. HBase gives you a nice kind of API where you can have record versions, which is often pretty handy for people. And there's also data durability and fault tolerance built into HBase. So if there's a failure, you should be able to recover, or you will recover, etc. HBase is not designed for large table scans, so like looking at your entire data set at once. It can do it, but it's not as fast as HDFS is, as we'll see in a sec. It's not really meant for batch processing, though again, you can do it, it's just not as fast. It's not meant for interactive SQL. It doesn't have a SQL interface yet. Currently, there is work being done to make Hive work with HBase, but it's not there yet. And also, transaction processing is not something really HBase is designed for. So, moving on, to show you what HDFS is designed for, HDFS is really designed for large data scans. It's meant to read a big data set from start to finish, and it's designed to make that happen quickly. Really, it's really good at that. It's designed for batch processing, right, using MapReduce or Pig or Hive or streaming, looking at lots of data, processing that data, creating aggregates, etc. And just like HBase, data durability and fault tolerance is built in. If you have machines fail, the cluster's fine, etc. What HDFS is not designed for is it's not designed for serving queries in real time. It is designed for throughput, not latency. So it's not something that you would expect to be real time. And then you also cannot update or delete individual records, which is usually fine for a lot of use cases, but sometimes not fine for some use cases. So to show you some examples of HBase and HDFS, you should use HBase for the following things. You want to serve content either on your website or REST APIs or any other APIs, anything interactive, right? You need to serve reference data, including maybe change the reference data. So in this case, maybe your mappers are going to be doing some joins on log files or sensor data, and they want to join against the number of known sensors or the number your user table or something like that. Then HBase can definitely be a great solution for that reference data. Along with the reference data too, HBase is really handy for keeping state for MapReduce jobs. So MapReduce jobs can use HBase to keep state, to know where the job is going, etc. And finally, HBase is really handy to power your heavy processing workloads, right? When you're reading tons of data and processing tons of data. Really good for complex data management. You can store images, you can store video, you can store text, anything in there can be processed, can be stored effectively, and so it's really good for complex data management. And lastly, HDFS is definitely powerful for data cleansing and transformations. Cleaning up your data, transforming it from one format to another. HDFS is very good at that because those are typically table scans. They have to look at all of your data is good at. So with that said, we'll do a quick poll, and I'll give it over to John to do the poll. And then again, we'll get to your questions in a second.
Thank you, Alex. So clearly, Alex is a deep well of knowledge when it comes to Hadoop and related technologies, which is fantastic. And we have plenty of questions, as Alex said, that we will get to here at the end. So what I'd like to do is just do another quick poll whilst we have you. So let me launch this poll. And this will help us with activity for follow-on presentations to you. So we just want to take just a moment, if you will, and you can select more than one of these. Given these list of topics, which would you like to hear more of. So please go ahead and select the things you'd like to hear more of. More technical details on Hadoop deployments. There is probably hours of time that we could spend discussing that with you. Case studies on companies who have deployed Hadoop successfully, so we can tell you about some of our customers and what they are doing with Hadoop. More information on related projects, so HBase and Hive. Clearly, we've just covered a little bit on HBase, but there are other related open source projects that help and support when you're doing your Hadoop deployment, and we can certainly give you insight into those. Many contributors for those other projects work here at Cloudera. How Hadoop will fit into your enterprise, just give you some insight into different integration options with the various data sources that you have. Omer mentioned BI tools, databases, relational databases, enterprise data warehouses. Those are certainly things that we can help you out with. And then finally, give you a little bit of insight into who comes up with some of these funny names, Hive and HBase and Hadoop and many of the other things that come along. So looks like everybody has answered. I will keep it open for just 5 more seconds, and then I will close the polls and share that back with you. So let me close that information, and I will share this information back to the audience. Actually, what I'll do instead of sharing that, why don't I just go ahead and let Alex get right to many of the really good questions that we have. So I will, now that the polls are closed, I will go back to the presentation. Yeah, there we go. Thank you. So let's move on to some of the questions. We've been collecting the questions for you. I'm going to pass it back to Alex to continue to answer some of the questions. You can continue to keep those questions coming in, and if we don't have time, there are many questions. If we don't have time to get to those, then we will absolutely get back to you individually regarding your specific question. So let me turn it back to Alex.
Thanks, John. So I'll just run through these really quickly. The first question is, can we completely turn off the shuffle and sorting in the merge process? The answer is no. Unfortunately, the only thing that you could do is you could specify a comparator which did a constant time comparison or a fake comparison, but there's still going to be a sort and there's still going to be a merge, and there's no way to turn that off. That's part of what MapReduce offers. Or that's part of the API. Why did turning on speculative execution solve a problem with reducers getting stuck? Let's say your reduce is running and maybe you have a slow reducer. Well, speculative execution will run that reducer in parallel on different machines, and those reducers will all run in parallel, and the first result will be taken. So speculative execution helps you avoid slow hardware or slow machines. What it doesn't help you do is avoid the case when one reducer has more work to do than others, because then those parallel duplicate tasks are going to run just as slow. Is compression replaceable? If you write a file that is compressed with LZO or something, you would have to run another MapReduce job which read LZO and which wrote gzip. So compression is not in place. You can't do in place replacement, right? But you can certainly translate your data from one compression codec to another. Some of you said that the Cloudera LZO doesn't work, and so you should contact us to get access to that. We have a big knowledge base of information, and we can provide more details there. You should see on the slides there that Omer and my contacts there. Feel free to shoot us an email, and then we can talk about how to get you access and that sort of thing. Moving down the list, can you reiterate the formula for mapred.reduce.parallel.copies and tasktracker.http.threads? Yeah, so these the formula is the number of nodes times the number of maps per node divided by 2. So the number of nodes times the number of maps per node divided by 2. And again, that's a pretty good kind of rough value for something that will scale with your cluster and be performant. Can we have an automatic name node backup? It's still a single point of failure. Well, actually, I'll take one at a time. Can we have an automatic name node backup? There is no way to do an automatic name node backup. you have to do it by doing, basically it's as simple as just doing 2 curls, so it's not complicated, and then just writing to an NFS. You know, one of the things that the community's working on and that we're also working on is trying to really address this the single point of failure, which currently is the name node and the job tracker. But with backups, the only risk that you have is that you might have a little bit of downtime. There's no risk of data loss or anything like that. So it is true that the name node and the job tracker are single points of failure. But you know, one of the things that I like to say when people have this worry is that, you know, Hadoop, it's a batch processing system. So it's going to be running jobs at night. It's going to be running long jobs during the day, or small short jobs from analysts. And because of this, pretty much all of our customers, or most of them at least, and most of the community are fine with having these be a single point of failure because they fail so infrequently. And when they do fail, since Hadoop is a batch framework, it's not something that your production website or your production REST APIs is relying on. It's usually okay to have a little bit of downtime. And also, for what it's worth, a lot of the people that we talk to, a lot of our customers, their name node and job trackers fail almost always because of user error, not because of hardware. So that's a different problem in and of itself. What do you do after the name node crashes? Well, if you have a backup, then you can basically restore from that backup. The link that we had there has more information about that. It's basically as simple as just putting the files in the right place and starting the name node. What data do we lose then? There's a possibility that if you roll back maybe a night or something, so let's say you have an hourly backup and you have to roll back to that backup, then you'll lose the day's worth of data, but you shouldn't lose anything else. What is the reason HBase is not good for large table scans or batch processing? This is something that, so HBase is mostly, it's getting better at large table scans and batch processing. It's currently not there yet. The HBase community is working very, very quickly on really improving HBase, making it better, and having more efficient large table scans and batch processing is something that they're working on. But currently, it's not as good as HDFS, at least for those two things. Let's see here. Isn't that just an extreme case of a very wide range scan? I see what you're saying. Yeah, a large table scan is an extreme case of a very wide range scan, but that's the point, is that HBase currently isn't optimized yet for very wide range scans. It's good at range scans, but very wide range scans not so much. How can you start and stop all the daemons in your cluster in parallel? There are several distributed shells out there. So there's like PDSH. There's lots of other distributed shells, and so you can use that to in parallel run a command on all of your nodes, which would then just stop or start the daemons. You can also, if you turn off LDAP and you just have a for loop and an SSH and a for loop, that actually works surprisingly well. But having LDAP and having those logins take a little longer slows things down. So I know it sounds kind of strange, like, oh, I have several hundred computers, and you're telling me to do a for loop with SSH. It actually works okay. And then if you want to do things more in parallel, there are parallel shells out there like PDSH and cap shell and other things like that. Let's see, going down the list. Okay, here's another one. Doesn't HBase use HDFS? So HBase does use HDFS, but HBase uses HDFS behind the scenes in order to achieve fault tolerance for itself. So you, the user of HBase, don't actually need to know or care at all that HBase uses HDFS. Behind the scenes, HBase is using HDFS to do fault tolerance in the event that there's a failure. But that's kind of beside the point. If you load data into HBase, that data will not be accessible in HDFS. The files that are written to HDFS by HBase are for HBase. They're not meant to be consumed through HDFS. Let's see. Yeah, there's another question here, and maybe Omer, you could jump in and take this one. The question was, it would be very useful to clarify how Hadoop is different from other data warehouses, Astrodata, Greenplum, and they have MapReduce support. So Omer, you want to take that one?
Yeah, I'd be happy to answer that. If you think of the underlying structure as we kind of walk through it for Hadoop, HDFS really is designed for storing whatever data you happen to have. It could be complex data, it could be structured data, it could be everything from images to log files to CSV files. It can vary in terms of types of compression. You basically can do whatever you want and optimize it for your specific task. And then you get to run things like MapReduce and HBase on top of that to do the processing in place. Other databases that have MapReduce built in, they also have that ability to do MapReduce, but they're doing it on structured data. So in most databases, you define the schema ahead of time. You conform the data to the schema, throw out data that doesn't fit, make sure ints are ints and varchars are varchars, and then analyze that data once it's fully structured and all the relationships are intact. If your questions are such that you don't quite know what the relationships are, you don't quite know what the data format is, you actually want to be able to analyze data that's a little dirty and that actually has an impact on your analysis, then you should be using Hadoop and Hadoop MR. You're not going to be able to do that inside the data warehouse. And conversely, the data warehouses are optimized for doing analysis and even MR on data that is fully structured and fully baked.
All right, so there's one more question that I have here, and that is any hardware guides for the name node. So this is actually a common question. A lot of people ask us, well, can we harden the name node? Can we use RAID on the name node, et cetera? You know, it definitely makes a lot of sense to kind of harden the various master nodes, the name node, the job tracker, et cetera. A lot of our customers will use RAID to do that. They'll use redundant power supplies. They might use enterprise hard drives, and it does, you know, it does make a lot of sense to do that, just so that way you're trying to make that single point of failure a little easier to deal with. Again, it's in all the stories that we hear and in all the experiences we've had, the name node and job tracker become available. Or become unavailable because of user error much more often than hardware failure, but it does make sense to harden those guys. So we've seen people running just mirrored RAID 1, some people run RAID 5, some people run RAID 10. I think the most important thing is for you to choose hardware that you're comfortable with. One of our customers decided on a RAID controller that they didn't really know much about, and unfortunately it caused a ton of problems for them because they had trouble managing it, they had trouble dealing with it. So, you know, it does make sense to have a hardened name node and job tracker, but just make sure you kind of know what you're getting into. Make sure you're comfortable managing the RAID array, that you know what RAID controller you're buying and how it's good and how it's bad, etc. And so I guess in summary, if you have the interest, if you have the money, and if this is something that's important to you, definitely makes sense to harden the name node and the job tracker. But keep in mind too that user error is often going to be you know the problem, unfortunately. So so with that said, there's a few more questions rolling in. Let me see here. Here, I'm going to turn it over to John now.
Thanks, Alex. So with that, I'm actually going to conclude our webinar today. I want to thank our speakers, Omer and Alex. Clearly, they have a deep depth of knowledge around Hadoop. If we did not get to your question, I want to assure you we will get to you and follow up with you offline and make sure that we get your questions answered. Again, we appreciate your attendance. We appreciate your answering the polls, and look forward to speaking with you again soon. Thanks very much, and this concludes the webinar.